Now it's time to look into a simple example to find out the statistical significance between the relationship of two categorical variables. If you want to put it in another words, nothing but doing a univariate selection. We want to select categorical features for a categorical target variable. For that, we need to take a chi-square test of independence. By using chi-square test of independence, you can basically select a feature if the feature is categorical variable, and if the target variable is also categorical, then the chi-square test of independence comes for your rescue. So let's see this example, the much simpler example. You may face much complex data, but it's simpler example. So let's consider a real world example to demonstrate how to test the statistical significance of the relationship between two categorical variables using the chi-square test of independence. So let's begin with the problem statement. Suppose we are analyzing customer satisfaction data for an e-commerce company. So let's get into the data and let's see. And this is what is our data frame. Let's see the data frame. Yeah. So our company is e-commerce, and we have two categorical variables here. One is shipping method, and the second one is satisfaction level. So the shipping method variable has three categories. One is standard, second one is express, and the third one is same day. On the other side, we have the satisfaction level as the second variable, and this has again the four categories. So which is very satisfied, satisfied, neutral, neutral, and finally dissatisfied. And this is what is the data story, and this is what the story about the data frame that I have. Okay, so now let's get back to the our chi-square test procedure. So we want so our aim here is to we want to determine if there is a statistically significant association between the shipping method used and the satisfaction level of customers. Now, so here is how we can test the statistical significance using the chi-square test of independence. So let's begin with the hypothesis, setup hypothesis. Let's see what all two hypotheses we can set up. So let me scroll up a bit. Yeah, here you see setup hypothesis. Yeah. So data frame or data story was done. Then after that, it's setting up the hypothesis. Null hypothesis for us here, there is no association between shipping method and satisfaction level. And on other side, alternative hypothesis says there is an association between shipping method and satisfaction level. If you see, if you put it in much simpler way, in basically with respect to the chi-square test of independence, when we say null hypothesis states that there is no association or relationship between the two categorical variables being tested. So it can be represented mathematically as the expected frequencies being equal to the observed frequencies of the observed frequencies if the variables are independent. So that's what, if you want to put it here. So what I can do is for specifically null hypothesis. For null hypothesis here, what we say is when we say there is no association between shipping method and satisfaction level, what does that mean? is there, there is no, like when we say expected frequency is equal to the observed frequency. So expected frequencies of all is equal to the observed frequencies. That's what they're saying by and large. That's why there is not much of there is no association between the shipping method and satisfaction level. So that's what is our null hypothesis. On other side, in the alternative hypothesis, we will say that there is an association between the same shipping method and satisfaction level, which means so expected frequencies is not equal to observed frequencies, and that's what the mathematical representation of null hypothesis and alternate hypothesis in our case. So now let's move on to the third step, because setting up of hypothesis was also done. Now it's time to gather data. So it's we have done this step earlier, but still, so you have to load data from a local machine or DB servers of sample of customers recording their shipping method and corresponding satisfaction level. So that's what is our third step, and then slice the required data from the table. So now the fourth step, the most important one, once your data is ready, you have imported the required libraries. Here stats is most important for to creating to do the computations. So anyway, so we have our data set. Now it's time to create a contingency table. Contingency table, we have done it in earlier cases also. So for to make a contingency table, we can use a cross tab. So construct a contingency table. So let me show that. That's what we're going to do now. So this is what I have done. After the null hypothesis and alternative hypothesis, I have gone for contingency table. I have created a contingency table. So let's create a contingency table that cross tabulates the frequencies of the two categorical variables. The table will have rows representing the shipping methods and column representing the satisfaction level. So as I have said, rows representing the shipping method. So I had to give that argument first. Then we have the columns, so satisfaction level, and then I have to give this one in later stage. So let me execute, and if you want to see separately, so this is our df. Let's print d and f, and also print uh, this is od, original data frame, and here it's a contingency table. Contingent table, it's contingency table, and if you execute unterminated df, okay, that's fine. Sometimes it happens. Yeah, what you got is this is your data frame, and if you see, this is our contingency table, and here you got, so no, the number of times satisfaction level and expression has been repeated. You can say that as an intersection of satisfaction level and expression in whole population, and similarly dissatisfied and same day, so very satisfied and standard, and that's what the contingency table that we got. So once we are done with contingency table, so now we have to move on to the next step, which is very important step here, to calculate the expected frequencies. So it's pretty complex one to calculate. Of course, expected frequency calculation with the chi-square goodness of fit is slightly different than compared to the chi-square test, chi-square independence test. Okay, so let's calculate the frequencies. Just see the for how to calculate. So compute the expected frequencies assuming the independence between the variables. So these expected frequencies can be obtained by applying the row and columns total of the contingency table. And this is what let's say this is our observed frequency. It's just an example. It's not exactly our data, just an example. So where the intersection of male Republican is 120, male Democrat is 90, and male Independent is 40, and the total Republicans are 230, and total Democrats were 185, and Independent were 85, and total male 250 and total female 250, and total population of sample size. Let's take it as sample, and total sample size was just 500. Just 500. Okay, so that's what our observed frequencies. Now to calculate these are observed frequencies. That's what we observed from our when we collect the sample, or what we got from the data set. But if you want to calculate the expected frequency, then we have to use this formula. This is nothing but the expected frequency of each row, expected frequency of each cell is equal to row sum of that row multiplied by sum of that column divided by total. So if you take first example, 250 times and this one 230 all divided by 500, and what you get is closer to the 115, and that's what is expected frequency. And here it is, you got 115. And if you take others, Democrat and Independent, so you got around 42.5, which is again intersection between the male and Republican. And this is how we calculate the expected frequency from the expected frequency has been calculated from your observed frequencies. And expected frequencies output, let's show it as a y, and row sum and column sum are x1 and x2, and table sum is x3, and what you got is a function format. Okay, so that's how we calculate the uh, expected frequency. We will be calculating expected frequency through the stats library. So that's the reason it's just a second's job for that library. Okay, now let's move on to the next step, and the most very important step is to perform the chi-square test. So now let's perform the chi-square test. Let's get into the action directly. So let's perform the chi-square test of independence. So chi-square, this is going to get the observed chi-square statistic, then p-value of observed chi-square statistic, and degrees of freedom, and expected is nothing but your expected contingency table, or expected frequencies contingency table. So let's execute, and as you have seen, this is our contingency table, and this is our chi-square test statistic. It's 6.44, and p-value is 0.37. Degrees of freedom is 6. Degrees of freedom is nothing but your degrees of freedom, which is calculated as a number of rows minus 1. Basically here we have 3 rows, so 3 minus 1, that's 2, multiplied by number of columns we have 4, and 4 minus 1, it's so 3 minus 1 and 4 minus 1, it's 6, and what you got is the degrees of freedom 6. And expected frequencies that we will be calculating, and what you got is 0.75, 0.75, 1.15, and 0.375, and that's what you got. If you take that, this is 3 times, and this is 3 times 2 divided by 2 6. Okay, it makes sense. 0.75, it's correct. And that with that we have calculated the chi-square test statistic, and p-value, and degrees of freedom, and expected frequencies, and that's what so the most of the work has been done with this. So we have even calculated the degrees of freedom. So now we'll be deciding with the most important aspect, that's a significance level. So I'll go with 0.05 significance level to determine the critical value, or to obtain the p-value associated with the chi-square test statistic. So final step is to interpret the results. So if the calculated chi-square statistic exceeds the critical value of the p-value, is below the significance level, reject the null hypothesis. Conclude that there is statistically significant association between the shipping method and safe and method and satisfaction level. So if the p-value is above the significance level, fail to reject the null hypothesis, indicating no significant association. So let's look into the remaining example. Yeah, so we have determined the significance level based on p-value, which is 0.05, and if the p-value is less than significance level, then we reject the null hypothesis, and we say there is a statistically significant association between the significant shipping method and satisfaction level. On other side, if p-value is greater than significance level, then we will fail to reject the null hypothesis, and there is no statistically significant association between the shipping method and satisfaction level. And let me see what the p-value that we got, and here, so if you say that this is our chi-square, this is what our p-value. So p-value is 0.375, and 0.375 is greater than 0.05. That means we failed to reject the null hypothesis. So there is no statistically significant association between shipping method and satisfaction level, and that's what happens with your chi-square independence test.